Okay, so for the next few videos, we will be discussing about the transformation of the graph. Right, so we are talking about the transformation of graph that involve a few types of function. Okay, so from here in the learning outcome, you can see that a few transformation involved, such as translation. All these are translation, and then we are having the stretching as well. Okay, and also you need to learn about the simple combination of all the different transformation mentioned here, right? Okay, so before we start in details for the transformation, we can have a look for all the basic curve. Okay, basic curve for all types of different functions first that will be covered in the syllabus. All right, so the first one will be talking about linear function. Okay, so when we are talking about the linear function, right, the graph will be the straight line. It can be either the horizontal straight line. As an example, this is a horizontal straight line, and the equation, general equation will be y equals to a number b. Okay, it can be y equals to 3, y equals to -2, and so on. And the second type of straight line will be the vertical line, where the general equation will be x equals to a number also. As an example, x equals to 3, x equals to -1, and so on. All right, then another type of straight line will be y equals to mx plus c, where the general function is y equals to mx plus c. So it depends on the m. If let's say the m is positive, then your graph will be going up in this direction. But if your m is negative, then your graph, the direction of your graph will be something like this. Okay, but all these are the general equation for the straight line. All right. Okay, so if let's say you want to know more detail about the straight line equation, sometimes the question will give you the general form, which is ax plus by plus c equals to 0. It can be given in intercept form and also the gradient form, y equals to mx plus c. In general, in our syllabus, mostly we will see that the equation are given in the gradient form, which is y equals to mx plus c. So you're having the gradient form, you can roughly know the direction of your graph or your linear function depending on the value of the m, whether is it positive or negative. So this is the first type of the basic curve that we have, which is the straight line or linear function. Let's proceed to the second type. For the second type, we're having the quadratic function. So for quadratic function, generally it's very straightforward, where we will have either the U shape or N shape. Okay, so all these are quadratic function. Okay, so for the quadratic function, the basic curve will be U shape or N shape, where it depends on the value of A. Okay, the value of A, which is the coefficient of x squared, to determine whether is it a U shape or N shape. So this value A is positive. Therefore, your quadratic function will be a U shape. And if your A is negative, then basically your quadratic equation will be having the N shape. Okay, so this is a basic function or basic shape for the quadratic function. All right, then when we are having ax squared plus bx plus c, then generally the x-intercept and y-intercept will have a certain value, where we will need to further investigate it to know the coordinate for the x and y, the x-intercept and also the y-intercept, or maybe the maximum or minimum point. Right, but in basic, in general, the quadratic function, you're having either the U shape or N shape. Okay, so you can see that the basic equation y equals to x squared, it is actually a U shape, right? Okay, so for quadratic function, right, if let's say you want to investigate further about the x and y intercept, or maybe the maximum or minimum point, the useful technique will be the complete square form, where we already learned it in chapter 1 earlier. Okay, so by having the complete square form, by having the quadratic function in complete square form, basically you can know a lot of things. As an example, you can know the U shape or N shape for the quadratic function from the value of A here. Okay, and then you can also know the coordinate for the turning point. All right, the coordinate for the turning point, either maximum or minimum point, by looking at the value for H and also the K in the completed square form. All right, so all these are very useful information that you can get from all these type of equation. Okay, so this is generally what we have for quadratic function, either a U shape or N shape. Right, then the third basic curve that we need to know is the cubic function. The the straightforward, the basic cubic function is y equals to x power 3. And then the y equals to x power 3, you can see that the shape roughly is something like this. Okay, you will pass through the 0, 0. Okay, then the curve will going from low to going from bottom to top. Okay, and if you are having a more complicated cubic function, then the equation is like something like this: ax power 3 plus bx squared plus cx plus d. Then your curve might have a more obvious maximum or minimum point. Okay, but in general, the basic, okay, the very basic shape for a cubic equation will be something like this. Right, then proceed further. For type number 4, we are having the graph of absolute value function, or we call it as a modulus function. So for modulus function, right, in detail, we will cover the equation and everything in A2 syllabus later. But for now, maybe we just try to learn, or maybe try to observe okay, the shape of a modulus function graph. So for any modulus function graph, basically it will be a V shape. When you're having y equals to modulus x, the graph will be a V shape. And you can see that modulus function means that we are changing all the negative value become positive, right? So from the diagram also, you can see very clearly that we are having all the whole graph above the x-axis, where it is always a positive value for the y. So it will fulfill the definition for the modulus function, right? Because modulus sign actually makes all the negative value become positive. Okay, therefore your graph will be always on above the x-axis. And the basic modulus function, the shape is actually a V shape here, like what you can see from here, from this part. Okay, so the more details knowledge about the modulus function will be covered in A2 level later, A2 syllabus. Okay, then next, let us talk about the graph of rectangular hyperbola, or we will say that when we are having something like a reciprocal function. Okay, in this part, I'm using the general formula where x times y equals to c squared. A more commonly seen equation that is linked to this part can be something like this, where you can have something like y equals to 1 over x. Okay, or y equals to 2 over x, 3 over x, or any other thing. Alright, so in general, it should be y equals to 1 over x or c over x. When you're having this kind of equation, right, in general, the graph will be separated into two pieces. So one piece is here on the first quadrant of the coordinate system, or of the Cartesian system. Another one will be in the third quadrant of the Cartesian system. Okay, and you can see that for these two pieces of graph, right, the graph for this part, like what I show here, will go up and getting closer and closer to the y-axis, but it will not touch the y-axis eventually. Okay, same thing happens for the x-axis here. At this end, the graph is getting closer and closer to the x-axis, but it will not touch the x-axis at the end. Alright, therefore you can see that the same pattern, okay, can be observed for this part of the graph as well. Getting closer and closer to the x-axis, but it will not touch it. This part we are having getting closer and closer to the y-axis, but the graph will not touch the y-axis. Alright, okay, so for this part, this is a general idea about the general shape about the rectangular hyperbola. And then we maybe can learn up this specific word. When you are seeing that your graph moving continuously and getting closer and closer to a certain line, right, but it will not touch a line. Like for this example, the x-axis here, I will call it as asymptote. Okay, so another asymptote for this pattern of the graph will be y-axis. So the y-axis will be actually the asymptote for the graph as well. Alright, so in general, the graph of rectangular hyperbola will having asymptote usually. Alright, in general. Okay, so this is the basic shape for the graph y equals to c over x, or y equals to 1 over x. Right, so this is one of the pattern for the rectangular hyperbola. Then proceed further, we are talking about the positive square root function. So when we are having the positive square root function, means that in front of the square root, it is a positive sign. So we are having the positive square root function. And then the graph of positive square root function, you can see that it only exists on the right hand side, okay, of the y-axis. Okay, so you can see that it is only applicable, or the graph only exists on the right hand side of the y-axis, where this part means that x is greater or equals to 0. And if you try to understand the graph and also the function, right, you will see that they are tally, or they are true to prove each other, because x greater equals to 0. If you put the value inside here, then only you get a value for the square root function. If let's say your x is negative, when you put it inside the function, then you won't get the value for square root negative something, right? Negative value, square root negative number. Alright, so you can see that for the square root function, it only exists in the positive part, okay, of the x value. Alright, and then the function is not defined when x smaller than 0. Okay, then next one. Let's talk about the graph of trigonometry. Okay, so in this part for AS syllabus, maybe I just try to cover a few basic trigo graph. The first one will be the sine x graph. The second one will be the cos x graph. And the third one will be the tangent x graph. Okay, so for the sine x graph, I will just draw a one-cycle graph for sine x in the notes. Okay, there are a few important points that we actually need to know. The first important point will be the starting point here, where it is actually a 0, 0. And after that, we need to know where's the maximum point. So the maximum value of the sine x graph is a 1. And what is the x coordinate when y equals to 1? So you need to understand that for x coordinate, it is actually pi over 2. The third important point will be this one, where the x-intercept will be the pi when y equals to 0. Next important point will be the minimum point. So for this minimum point, we need to know that the minimum value for the graph sine x is equals to -1 when the x value is 3 pi over 2. And next important point will be this one, where the x-coordinate, x-intercept, okay, is 2 pi at y equals to 0. So all these are some important points that that we need to know. It will be better if we know about it, so that it can be a reference point, okay, for us to observe the transformation of the graph later. Okay, so when we know all the basic shape of the graph, right, if can, we try to remember some important coordinate of the graph, so that it can help us to identify what kind of transformation we have or being asked in the question. Alright, okay, then next one, we are looking at the cos x graph. So again, a few important points that we need to remember. For cos x graph, again, maximum point will be the 1, and this coordinate will be 0, 1. Okay, so the next x-intercept will be pi over 2, 0. Minimum value will be equals to -1 as well, and the coordinate for this minimum point will be pi and -1. Next important point will be this, where x-intercept is 3 pi over 2 with the y value 0. And lastly, the last point in the cycle is 2 pi for the x-coordinate and 1 for the y-coordinate, which is the maximum point. Alright, so all these points are comparatively, if can, you try to remember it. Alright, it might help us somewhere else when we're trying to answer the question later. Okay, then now we proceed to the tangent graph. For the tangent graph, right, first we need to know that they are having the asymptote lines. You can see that all these are the asymptote lines. All the dotted lines here are asymptote lines. Okay, the more important asymptote, you need to know the x-coordinate for the asymptote line. So for this one is pi over 2. Okay, and we are having negative pi over 2. And the next asymptote line will be 3 pi over 2. All these are the asymptote line for tangent x graph. And then you can see that the graph is starting from the lower part, the negative value from the graph, and going up. And where's the important point that we can remember? So the important point that you can remember is this one, where it will pass through the 0, 0. It will pass through the origin. And another important point I feel is this one. when I'm having pi over 4. Okay, then you need to know that tangent pi over 4, it is actually a 1. So to me, this value itself comparatively is one of the important value or important point that I should know for tangent x. Okay, alright, so by knowing all these basic graph, okay, for the certain type of function, it will help us to identify a certain type of transformation later lah. When maybe the question is asking what kind of transformation is having for the graph. So we can start actually from the basic graph that we learned here. There are a few types here, right? So if we know all the basic graph here, then later we want to identify the transformation, it will make our work easier. Alright, okay, so if possible, try to remember all the basic curve, all the basic shape of all these functions. Alright, and then we'll proceed to discuss more on the transformation of the graph later in the next video. Alright.